off with a last time, and we said that natural log of 1 over e
No.
can be solved by rewriting e as e to the minus 1. Carlo. And then by the inverse property, that left us with minus 1 because the natural log of e to the anything is just that thing. Okay, so we're going to do b now. Let's see. I think we stopped on. I think we stopped with Maya. So Sydney, how do you want to approach b?
Not really.
I mean, I said it. Not do you want to? How do you want to approach b?
Oh. Wouldn't it be? It's like the what's the equation that's like c b squared?
I have all the equations up there,
But it's
and you have all the equations in your notes.
I gotta take a picture.
oh. Wait, I don't know which. Wait, no, go back.
No!
Take your own notes.
Yeah, but if it was not, I'd stay there. I mean,
We did this. The entire last class was everything except for this. Everything up there is what we did the entire last class while you were diligently taking notes.
yeah, but
Carlo, what we did last time was we just restated all of our properties for logs in general with a as a generic base, and then we applied it to base e. So please write down, if you want to write down both columns, that's fine. If you want to write down, at least write down the columns and the reasons for the properties of natural logs. That's where you should be starting, and we're applying all of these natural log properties. Charlotte,
Can I give the thing?
what do you say?
5
5 why?
because it's number 4 inverse property.
And that allows you to cancel what?
The e's.
The e to the natural log of 5 just equals 5 by the inverse property. All right, let's see. I'll take a volunteer for number C. Warren?
0.
Why?
Because like the thingy at the top is 0.
The numerator is 0.
Yeah, so it's gonna be 0 over 3.
Why is it 0?
Let me check what property that was.
You're up on the board.
Yeah, it's up there.
They're on the board.
It's up there.
Oh yeah, because a to the 0 equals 1. Hell yeah.
Same, you want to do number D?
Or surely don't, but I know you're gonna make me.
Yeah.
Yeah.
So what I would do is I would put 2, 0. That's wrong. I don't know.
Do you see a property of logs that helps you figure out what 2 natural log e is?
Well, let me look, sir. I'm gonna say I don't.
If you wrote down 1 through 6, then you have it.
I wrote down literally everything, and I don't know what I'm looking for. So, un momento, por favor. Uh-oh. Help? Question mark?
So the reason why natural log of e, well, we can figure that out, is because any number, if you don't write an exponent, it's understood to have what exponent?
10. 1. Oh wait, yeah, 1.
Just
I think about the
just
natural-
a
I think
random
about the
number.
log thing.
A random number. That's not 8 squared. It's not 8 to the minus 3.
1.
It has an implied power of 1 if you don't specify it. So this natural log of e can be written as natural log of e to the 1. But then using the cancellation property, the inverse property, I mean, then that leaves you with what, Sam? So you actually got a couple of choices on which property you want to use. There's a couple. So which one did we use to cancel?
It's a natural property, right? Or
It's on the natural logs column, but it's true because it's a property of any log. So it's kind of on both columns.
Is it perchance 5?
Warren,
Yep.
can you look at me?
Yep. Sorry.
Is it perchance number 5?
No, because we don't. If it was 5, then we would need ln of something equals ln of something, and then we would set the somethings equal to each other. That's what number 5 is trying to do.
Yeah, I got nothing.
Which one is letting us cross out? Like when we did number B or A, we crossed out. What properties were allowing us to cross things out? Like, do you see that?
Do I know that?
Yeah. So you see for 3 and 4, they're letting us cancel. These are inverse properties, so they can cancel out. These are inverse properties, so they can cancel out. So that just leaves whatever that exponent was, whatever that x was. That's all we have left.
Well, I just didn't see it. There's an. Is it 3?
Property 3, yeah.
Cool. Let's use that one.
So let's apply number 3 to what we're working on down here.
I would agree.
And then what's left over after we cancel?
You ask great questions. It's one of your best qualities.
So what are we going to cancel? Like, you see how here we had e to the natural log of 5, and we canceled it, leaving 5.
Do we get rid of e to the 1?
No, we get rid of the natural log of e to the.
Oh yeah.
Natural log and
So
e
do
are
we scratch out the entire thing?
not in the entire thing.
Do we scratch out ln e
Yep.
and we leave to the?
No, the to part goes away. We just left with whatever that x was in the exponent.
Is it 1?
Yep.
Good stuff.
That's the way we did it just now. That was by property number what?
3.
Number 3. But here's a shortcut too.
No.
Here's a shortcut. Property number 2 is its own shortcut. So ln e is just 1 for that reason. So back to problem D. How do we use this newfound knowledge to solve D?
Repeat your question.
What is the answer to D?
1. No. 2.
2 because we had 2 out front, and then that was times 1, and so the answer was just 2. Nice.
Yeah.
Yep. All right, try these on your own using the list of properties. Try these on your own.
Is that 5 ln 1?
Yeah, 5 times ln 1. What?
What's if we-
It looks so.
It looks so amazing. It looks awesome.
Yeah.
That's what I thought.
Damn. Only to G.
Oh, I guess that's not D, is it? That's not D. Yeah, that's H.
Okay, can you rewrite H because I can't read it?
Plenty.
Your LN looks like an H.
Wait,
What is L looks like? So.
So H is LN times E.
What?
Oh my God.
H is E to the ln7.
That is the H. You're looking at the H.
What?
The LN is above the E.
E. Oh, seven.
I'm losing my mind in this
Oh.
class.
What's your shadle? Can you go back up?
Minus E.
Kira.
Mind
Thank
found.
you. Sorry.
Mind found.
Which one is G?
You want to see G bigger?
No, I'm just trying to figure out what row
G
that is.
bigger.
If only we had some sort of way of
I'm
finding out what
looking.
ln.
Shut up. Can we go for F and G, or are we gonna go over all of them?
Well, bro. Is there one that you want to volunteer for?
If I volunteer for E.
It's so easy.
Okay,
Which one's-
Eric, which one are you going to volunteer for?
Oh, E is number
What?
3.
Which one are you going to volunteer for?
No, I didn't.
Yeah, it's so easy.
You can assign one to me.
Which one do you want, Carlo?
You assign one to me.
I'd like you to do H, please, Carlo.
Okay. Oh.
Eric, which one are you going to choose?
And it can be every.
E,
F.
F?
Yeah.
Or who's going to do G? Who's going to do G?
I got it.
Amelia?
Okay.
Who's on man?
Which one is that?
Wait, no.
Oh man.
Properties.
No, I don't want it.
Is that correct?
I don't want it. I don't want it.
Okay, it's okay. No.
Does that look like brick?
Yeah.
Subconscious.
Why'd you write brick again?
It's like,
What is brick?
Better than poopy. Because there's no E.
I don't know.
So it's gonna be good.
like it's the first one, yeah.
Brick is like better than poopy. Property.
Oh, I
remember.
remember.
I remember.
I remember.
I thought this was like some like.
Annabelle, you ready?
Yeah.
Amelia,
Poopy! Ah!
What?
do you have answers for all 4?
No, I thought you said I only had to do G.
Huh?
So you said property.
I want you to do all 4.
I feel like I definitely did this last. I feel like I definitely did this last night.
What do you say, Annabelle?
So using property number 3, you can say that L and E times 1 to the 1/3 is 1/3.
Great.
Good job.
Yeah, good job.
Brick?
What? Brick. F is 0.
By number what property? By number what?
By number 1.
Good job. Amelia, what's number G?
Same, bro.
I did this last night.
Hell.
For a change, she doesn't know.
Yeah.
Says Amelia.
Okay. I don't know.
Yeah, you do. You actually do know.
No, I feel like I do, but I'm not gonna say it out loud because it's still the wrong answer.
How could you do it? What what were you doing while we were solving D with Sam? Where were you?
I was watching.
Yeah?
Okay.
What did you
okay,
get out of
so
it?
Is it 3/4?
Yeah.
Okay, that's what I thought, but I didn't know
I
if I was
forgot to type
stupid.
it.
Okay, so basically, E, if it's E to the 1, which it is,
Yep.
then that's just 1.
Yep.
And then L and E is just 1, and then 3/4 times 1 is just 3/4. Okay, sorry, that's what I was thinking, but I didn't know if I was stupid.
No, you're good. No, you're good. Which property do you want to blame?
Blame. 1. No, 2. 2.
Good job. Carlo?
It's equal to 1. No, it's equal to 7. because of property number 4. And
Which is also called the what property?
the inverse.
Nice.
Inverse property.
Nice. Good job.
I'm glad I have those proven.
I'm glad you handled those brilliantly.
That's funny.
Remind me what e to the, or let's just say, remind me what 2 to the x looks like, and what is the inverse property? It looks like, what? Give me a point that it goes through.
0, 1.
0, 1 is correct. And what's the horizontal asymptote?
I was aiming for
What's a horizontal asymptote?
I'm not.
Carlo.
Horizontal asymptote is the point at which it starts to reach infinity, so it's not viable.
Mm-mm.
What? You want to know the horizontal asymptote?
What is the horizontal asymptote of 2 to the x?
0.
Oh,
That's not a horizontal asymptote.
y
X equals 0. No,
That's a vertical line.
Y equals 0.
Y equals 0, right?
I'm sorry, slightly.
And then, so it's very small leading up to 0, and then it passes through 0, 1, and then what does it do after that? And then, what does the inverse look like?
Reflected over the x equals y line.
Reflected over x, y equals x. And so what would it look like?
You have a vertical asymptote.
Vertical asymptote now, so the horizontal asymptote gets flipped to a vertical asymptote. And then the actual graph goes, it hugs the vertical asymptote, and it reflects that way.
It goes through 1, 0.
And it goes through 1, 0
What is happening?
instead of 0, 1. What do you call the inverse? So if f of x is 2 to the x, and g of x is the inverse function of f, what is g to the x, Warren?
It's log base 2
Of
x.
x, that's correct. What is the domain of f of x? What's the domain of g of x?
Wait, what property was number A? Or letter A?
What reason?
Yeah.
So we had to rewrite 1 over e as e to the minus 1, and then we used the inverse property.
Okay, but like, what log property?
Inverse property, 3 or 4? 4.
Okay. Okay.
But on homeworks and tests, you're not going to say by number 4. You can say
You
by,
can't say that?
what's number 4? If you write out the properties and you have them to refer to, yeah, go for it. Say number 4. But if you don't write it on your test or homework, you can't just say number 4. That doesn't mean anything. It means something to this moment right now because we have it to refer to.
Okay.
You have to say by inverse property. Or for this one, just spell it out because a to the 0 equals 1 or a to the 1 equals a.
I totally would have put number 4 on.
Okay. I'm glad we had this chance to clear that up. Eric,
Yeah.
what's the domain of f of x when f of x is 2 to the x?
Oral number.
All real numbers. How do you want to write it? Kira. No, wait. Eric, you tell me one way, and then Kira, you tell me a different way.
Oh, well,
Eric first.
Is the parenthesis positive, negative,
Parenthesis. Sorry, you got me doing it now. Single of parentheses is not parenthesis. Parenthesis. And then what do I write?
negative infinity,
Negative infinity,
and positive.
comma, positive infinity. Okay, that's one way. That's correct. Kira, what's another way to write that? the symbol, what are the symbols?
It's an R with 2 lines.
So x is in the set of real
Oh
numbers.
yeah, X in the E thingy.
Yeah, the x is an element of the real
Element
numbers.
of all of them.
Right. And there's a third way.
Be awesome.
What's the third way? Third way is just English.
All real numbers.
All real numbers.
Good English.
What is the domain of g of x?
Oh, I like these. I did this in my homework. It kind of sucked, but you have to set it.
But you just said you liked them.
Well, yeah.
Set
but
what?
not really.
Set what?
You have to set the argument of the actual like.
So right now we have
logarithmic.
log base 2 of x. We have this graph.
Yes.
What's the domain?
Everything bigger than 0.
Okay, let's write it using this way.
0, infinity.
Nope, that's not it. That's not complete.
Parenthesis. 0, comma, infinity, parenthesis.
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 Carlo, how do I write it using the second way?
You do X E double R except less than 0.
You want x to be less than 0?
No.
What we want to say is
Equals all
it's
positive.
it's not except. It's such that. So it's x is an element of the real number set, such that x is what? What do you-
Positive.
So how do I write that in math symbols?
I'm not 100% sure.
Greater than, how about greater than 0?
Yeah, greater than 0.
Just like that? That's correct. How do I just spell it out in English?
All positive real numbers.
All positive real numbers. Okay, how do I say if f of x is natural log of x minus 2? This is a big leap unless you've already looked at the homework. What's the idea here? What do we have to do here, Kira?
Well, you wanna know that, like, whatever your asymptote is gonna be whatever makes it blow up, and then that's gonna help tell you your domain. Because it can't be small, like.
Natural log, log base 2 of x could be any positive number.
Yeah.
So, and that would be the case if it was natural log of x, or log base 10 of x, or log base 3 of x. So, what causes this equation to blow up?
2.
Carlo.
Sorry.
The thing that cancels it out. 2. Because negative 2.
So, what numbers are not allowed? So you could say you took this x and you said x must be greater than 0. So we could also do that here, and we could say this thing must be greater than 0, and then we can just do algebra on it and figure out what it should be. So how do I get x by itself?
Add 2.
To both sides,
Yeah.
and then that's my domain. So now it's so now I say I just take, well, I'll just rewrite it. I take what I wrote there and I'll say the domain is all real numbers such that x is greater than 2. It's kind of easy and straightforward in my opinion. Maya,
Yes.
if I have g of x equals ln 2 minus x, same strategy. What do I do? What's a domain? The idea here was that this can't be 0, can't be less than 0. This thing that's inside the parentheses has to be greater than 0, so that's why I wrote it out this way. Natural logs can't deal with 0, they can't deal with negative numbers.
Okay.
So what do you want to do?
I don't know.
Do the exact same steps that we did last time.
It's a chin shot, right? Okay, 2 minus x.
2 minus x.
I'm confused.
Do you see how because of the horizontal asymptote here for the exponential version,
Right.
this does allow any x values, but it can't produce, the range is not all values. It can't produce any negative numbers. All these negative numbers are out of bounds for an exponent, for the 2 to the x. And then when you do the inverse, the domain and range flip-flop, you can produce any number. For y, you can get any amount, but the domain is limited. So the domain, because of not being able to produce anything on the range on this part, can't get negative. The domain can't go negative. Can't. It's not allowed. It breaks
So
it.
it has to be greater than 0.
Yes. Whatever's in the parentheses has to be greater than 0. How do I get x by itself?
Subtract 2.
Subtract 2 from both sides.
And then divide by 1 on both sides and flip the sign so x is less than 2.
X is less than 2. Yeah, or you could describe it as multiplying both sides by -1 if you want to. But thank you for remembering, when you do that to an inequality, you flip the sign. So now my domain is all real numbers such that x is less than 2. As long as x is less than 2, you're good. Okay, this one's only slightly harder. Same technique. Sydney, you ready? What's the domain of ln x squared?
All real numbers except x is
Such that
x is greater than 2.
I disagree.
Can you take a square root of 0?
Is it like square root?
X
I'm
equals
confused on
0.
what I'm supposed to do.
It's the idea, the process is the same, like the approach is the same. What did we do on A and B, Sydney?
You took the parentheses out and then,
Yeah.
well, like you did math.
Yeah. So let's do the math part. Let's not
Yeah,
jump.
there's a parentheses, right?
Let's not.
Oh, am I supposed to take the square root of it?
No. We're just saying whatever you're taking the log of,
Uh-huh.
that can't be negative. This can't be negative.
So all real numbers
Will not be
greater
All
except that
real numbers.
Yeah, all
It's
real-
just
all real
real
positive
numbers.
numbers.
There's no.
Positive.
all real positive
It doesn't even
numbers.
have to be positive.
Give me an example.
Because -1 squared is just 1.
So if x is -1, h of -1 is natural log of -1 squared, which is natural log of 1, which is 0. So it's not broken by negative numbers.
It could be.
So all real numbers.
All real numbers. But this is why is
Oh, because if you set it to 0 and you take the square root, then you get just 0.
so if you say x
Square root of 0 is
x
0.
squared.
Is bigger than 0.
Eric, who are you talking to?
Yeah, what do you say?
Who are you talking to?
Yourself?
No.
Are you grumbling? Are you grumpy, Gus? What is happening?
Talking about us, he's like, oh, I hate
Are you grumpy?
Ah.
Are you mad?
No.
Was it something I said?
You're rocking her.
It's okay, Eric. You get a bed
He's hearing
drums next
Mandarin in the
class.
background.
Kira,
Well, if you
How do I set up my inequality?
bigger than 0.
X squared is bigger than 0.
Greater than 0. Yes.
Yep.
And then if you take the square root, you just get square root of 0 equals 0. So x equals like plus or minus 0, but that doesn't do anything.
So just be 0.
Yeah.
Yeah,
Because plus
so-
or minus 0 doesn't matter.
So really,
And
this
then-
this really turns into x is less than 0, or x is greater than 0. Well, it's all three. It's any real number.
But like, how does that come from just the square root of 0? It's
So
just 0.
just looking at this, x squared has to be greater than 0.
Yeah.
So what numbers make that true?
All of them.
Not all.
Well, like
Not all.
very, very small negative numbers.
A small negative number would be a squared small negative number, so it would be even smaller, but it would be positive. Like 0.1 times minus 0.1 times minus 0.1 gives you positive 0.01. But it's not broken. But what does break this? X squared has to be greater than 0. Greater than 0. Not greater than or equal.
0. So
Right.
it breaks it.
Right. So what do I want my domain to be?
All real numbers except 0.
All real numbers such that x is not equal to 0.
I'm the realist number.
Here you are, Carla.
Well,
What is happening? Try that again.
that's most.
Here we go. All right, let's graph that. Let's graph that first one. What did we say? What was the function, and what did we say the domain was?
ln x minus.
So I'm going to click on functions here, and I'm going to go to ln.
Go back up. I think. No, not all the way. Not that far. There. Calculus.
ln
X minus 2.
x minus 2.
And the domain was everything, all real numbers except x is greater than 2. Which is your vertical asymptote. Which
My
is
vert-
what I was talking about, that if you use your vertical asymptote, then that's like
Yes.
gonna be your,
I totally agree.
which is when I said 0 for the other one.
What's the second one?
2 minus x.
And what was our domain?
X is smaller than 2.
Smaller than 2. So same vertical asymptote, just on the other side.
Totally.
And then what's our last one, Carlo?
I actually don't know.
X squared.
Oh yeah, x squared.
Are you writing notes?
Me?
Yes.
Well, yeah, I am, but you know, I don't find it necessary to write down every equation.
Here's the graph. This purple one is the graph of natural log of x squared. And do you see how it has 2 branches now, but it does have a vertical asymptote at x equals 0.
How is it not a continuous graph? Like, how is it, because there's no spot that it would connect if it vertical asymptote on both sides was 0, so how is it just like,
It's not continuous.
it's not continuous?
It's not continuous. So it has a it has a vertical asymptote at x equals 0. Natural log of 0 is undefined. And natural log of negative numbers is undefined.
Oh, really?
Yeah, natural log of negative numbers is it's not a real number.
So you have
It's a
to
complex
have a real
number.
number for any natural log?
You have to have a positive. You take natural log of positive real numbers
Okay.
to get a real answer.
So if you had like 1 minus 2 as like, or like, if it was like 1 minus x.
So let's see what
and
let's see what
then
happens on the
x
graph.
equals 2.
We're at 1 minus. Let's do 2 minus x, but let's not do x. Let's do a slider. So I'll just say variable a. Oh, it's letting me. It gave me a slider for x. I'll just use that.
The X slider.
Oh, that's the x. No. That's weird. What if I write it again? What? Let's see. I'll do f of x
Do like H, F of H.
equals. What do you want?
Well, if you plug in a different variable than f of x, it'll give you a slider, because if you do x, it's going to be a function, and it's going to recognize that. Or like if you do a different, over there, if you do a different variable, I think.
So I want the slider to be. Let me see if it lets me do this. Natural log of 2 minus a. Yeah. It's a constant. That's not what I want. Let's do x minus a. That way I can go negative. It still has a vertical asymptote at a. So if I say x equals a is my vertical asymptote, that just follows along with whatever my value for a is.
That's cool.
All right, let's do
Do it in the writing.
human memory model. Students participating in a psychology experiment attended several lectures on a subject and took an exam period. Every month for a year after the exam, the students took a retest to see how much of the material they remembered, period. The average scores for the group are given by the human memory model.
This was in the homework.
No.
Or I saw it in the text.
No. Human memory model is f of t equals 75 minus 6 natural log of t plus 1, where t is between 0 and 12. And t is the time in months. What was the average score on the original exam?
Probably right there.
Can you scroll up just a little to get the
What was the average score at the end of 2 months? What was the average score at the end of 6 months? Eric, what is T?
T is the time. The time in months.
Time in months. So for part A, what is T? What is T to answer part A? Asking Eric?
When?
1 month later? No, we did, it's not 1 month later. It's the time at the exam. T is time in months after the exam.
Okay.
So the time of the exam, T is what? What do you say, Maya?
0?
Yeah. T is 0. Warren, what is T for part B?
It's 2.
It's 2 months. Amelia, sorry, Annabelle. What is T for part C?
6 months.
6 months. What was the average score on the test? So what I want here is I want to find f of 0